Yeah, thank you. Yeah, anyone? There's something in the chat. Uh, would you recommend knowing? I don't need to go further. I always recommend knowing. But okay, so would you recommend knowing how to use all the sort algorithms, or should we just know the best ones as well? So we have covered four sorting algorithms, as I recall. So if you look at past exams, like it's never the case that you would be asked like implement merge sort or something like that. Like never happened, right? So what sometimes happens is you're asked to use some of the ideas that, and like I'm not commenting on what's happening this year. I'm just saying in general, you look on past exams, and what you see is if there is anything that's related to sorting, it's not about like implement merge sort, implement counting sort. It's more like solve this problem, and it so happens that knowing how to, for example, do counting sort can be helpful. So I would recommend understanding all the algorithms, and I would recommend knowing at least one. So you saw, like, I think maybe last year, the year before, there was a question where you need to compute the median, and knowing how to sort in some way was useful. But more importantly, I recommend kind of internalizing the idea enough so that you can solve problems that are similar to the problem of just sort a list, right? And you treat, I think, generally algorithms this in this class the same way you treat examples, right? Like it's just another example of solving something useful, and it so happens that this algorithm has a name. Sorry, that was a bit long. So when should we count all the nodes in a tree, and when should we count the number of levels? So your goal when determining the runtime complexity is to either count all the nodes in the tree in case that every call of the tree it takes up the same time, or it is to kind of total up somehow the total amount of time that the algorithm takes. So in terms of counting levels, this is sometimes a useful trick, right? So like if you determine that this level takes this much, for example, this much time, then you can say, well, like this many levels times how much each level takes, that's the total runtime. So that would be kind of a trick to compute the total runtime. So that's the context in which counting the levels makes sense. Another context in which counting the levels makes sense is just like, you have like one on the first level, two on the second level, four on the third, whatever, eight on the fourth. Then you want to know like when does it end? So how many steps are there? That's the same as how many levels, and that's just going to help you count up how many calls there are. You are allowed to use anything unless it's explicitly banned. So, like, just I posted the first page on of the exam on Piazza. Just look at what that says. It does not ban this. Yeah, so like this is all kind of in the Piazza post. If you go, like the reference sheet is posted. There's some good ways. What are some good ways to sort a dictionary based on keys? Well, I mean, like a good way would be to get all the keys and then sort them, and then you can get the corresponding values. So like it's like easier than sorting based on values, because like you just sort, like sorting based on keys, if I understand you correctly, just means like sort the keys, then get the corresponding values. You could also get like the items of a dictionary and like convert them to and just do sort that, and that would also sort based on the keys. So And then again, like if you just need the keys, you need to extract them from this list of items, right? Yeah.
Yeah, but like, will the output like for like this method be like a set or like a dictionary?
It would be a list.
It'd be a list, but like, isn't it like items? Oh, so it's like a dictionary, a list which like contains like all the sets set with the items.
Well, yeah.
Okay, thank you.
Uh, for some cases, each level, the function only choose one node to run, and that is restricted. Yeah, that could happen. Yes. I'm not sure if that's part of the question, Cecilia, but yeah, like the answer is yes, that can happen. Yes. Uh, is it possible to see the solution to 2015 Q2? 2015 Q2. Yeah, it might not be posted. Uh, yeah, so like in general, like especially for like early questions, like go to ChatGPT, it'll get you, it's got you covered, to be honest. But are there any possibilities that Cecilia, sorry, I'm not quite understanding what you're asking. Like if you want to come online and say that. So yeah, so like Q2, I think that is like what we started writing here, right? So you could do something like, right. Yeah, so like something like this, for example, would work. Right. So like you get all the keys and then yeah. And then you just go through everything and uh so compute like this minus this, this minus this, this minus this. And then like if it's a zero, then that's what the dot get is for, where you get zero in case there's no key k. If both of those are zeros, then k is not going to be in here. And that's fine because 0 minus 0 is 0 anyway. So 0 minus 0 squared is 0. Yeah, yeah, Cecilia, sorry, I like maybe if someone else understands, I'm not understanding the question. Which means if the nodes are restricted by if statement, do we need to consider all nodes generated from the if statement? Well, if that's the answer, so let's maybe do an example like this. So that was like something that's come up in the other one. So let's say that I want like a recursive max. And the way I want to do it is I want the maximum of the first half and the maximum of the second half, and then I want like the max of both. Oh, Cecilia came back with. Okay, so let me finish this example anyhow. So this would be like this, and then I'll say like that, and then we'll say uh sorry, that was actually a bad example. So yeah, so I'll do yeah, okay. Okay, I'll do it the other way. Say right. So here there is well, like in a way, it's the same call, right? But we are kind of making the call twice in a silly kind of way. But if only one call gets made, then there's only one call in the tree. So Cecilia references 2015 Q3. What is this? Sorry, I'm not sure. Are you talking about 2015? Oh, I see. Yeah, so what's happening here is we are sending I and J to F. And initially, I is like 0.2 times n and 0.25 times n, right? So divided by 5, divided by 4. And then what's happening is at each iteration, either we send I and then halfway between I and J to IJ, or we send halfway between I and J to IJ. So either way, the new IJ shrinks by a factor of 2 because we're sending like either I and halfway or halfway and J. But we're just doing the one. And I think you were asking like, is the one call? And the answer is yes. So we can kind of represent it graphically as kind of like J minus I is equal to N, and then J minus I is equal to N over 2, and so on. And that's because J minus I like gets smaller by a factor of 2 every time, right? Because like you start with some J, some I, some J, and then it's either I and halfway or halfway up to J. And then you start with, where's my thing? You start with IJ, not exactly N, but like 0.05 N, because that's like 0.25 minus 0.2 times N, right? But it doesn't matter. Like it's the same idea. So like how much to get from 0.05 N to 1 if you divide by 2 every time? Well, it's log 0.05 N, which is log 0.05 plus log N. So, it's log N. Does that kind of answer your question? Cool. Anything else? Or yeah, like I need to submit like a bunch of reference letters actually that are due tonight. So
Yeah. Can I have like one more question?
okay.
So like when you justify like what's the worst case scenario, like for recursion questions, for example, do we
Yeah.
need to like, justify like why is our case the worst case?
Um
Can you
so
just simply say that
so
like
so,
you
so
have a
it depends on kind of what the question asks you to. Like the question, I think what I said in class is like there's not gonna be like a formal proof kind of thing. So if it's like not a formal proof, like just like tell me why your answer actually makes sense.
so I just need to tell like why I think like this case is the worst case.
Yeah, well, I like just like when you're talking to me and like you like not like as an instructor, but just like as a colleague, and you would say, well, it's like that, and I'm saying why? Like tell me what you would say.
Okay, thank you.
Okay. 20, 20, 2016 QA. What do you mean if the conditions are not symmetric? Uh, there, yeah. I mean, that's fine. Like what they were, it's not so much like the return, it's that the calls are like that. And it's like a similar kind of, well, like here actually you want to think about like the worst case kind of deal, right? So what's going on here very quickly? So P is the maximum between L0 and the last element. And then L1 start out empty. And then we're saying put everything below P into L1, put everything above or equal to P into L2. And then if L1 is greater than K, we call mystery helper like this. If L1 is not as smaller than K, then we do this, right? So basically what you say is, so basically what you say is, okay, the base case over here would be return P. So we terminate when length of L1 is not, so length of L1 is exactly equal to K, right? So what you want in terms of the worst case is to say, well, what is the largest number of calls that you can make such that length of L1 is not equal to, such that length of L1 is not equal to K, when L1 is all the elements that are smaller than P, right? So, okay, so, and then P is just like some number, it seems, that was picked, right? Like maybe it's L at 0, maybe it's L at -1, like the larger of them, right? Like one thing you could say is, well, in the worst case, what's going to happen is you're going to keep calling, and whatever list gets sent doesn't get much smaller, and K doesn't become smaller either, right? So in what kind of situation would that happen? Well, it would happen if K is very large, right? So if K is very large, you always do this. Sorry, K is very small, actually. So if K is very small, you just always do this, right? And the only way that things come to a head is if length of 1 is just, sorry, so K, so what, yeah, so what we want is for K to be very small so that length of 1 is always greater than K. And then what we want is for P to be such that L1 is as large as possible, right? So you could imagine and you could set it up so that P is such that L1 only grows shorter by 1 every time, right? So basically you're saying in the worst case, L is all of L1, and then L1 only grows shorter by 1 every time. So that indicates that you have like length of L calls, if that makes sense. Well, like in this case, I'm just gonna say, like, what's the worst case? The worst case is like you keep not returning, you keep calling and not returning. How would that happen? Well, like L1 and L2 get shorter, so eventually something's gonna happen. But I'll make it so that L1 doesn't get as short. So that was just like one strategy. And then like you can just reason here, well, like if you do it here, like clearly K, well, like changing K is maybe not a good strategy here. Because you make K, well, whatever, you make K smaller this way. But kind of the point is to make the list so short that this has to terminate. Sorry, was there another thing? Our 2015 8C. Oh my God. So the answer, like, so like the basic answer, like, so what I'm gonna do, I think, is I'm gonna give you, like, honestly, like, I don't think this is a good use of time currently right now. So the hint is this is not basically, this is actually merge sort, just implemented iteratively. So think in that direction and think about why this is all van log hint. Okay, small question. For a guy who has non-uniform, what is non-uniform merge? It's just merge sort. Uh, for a guy who is somewhat understanding what is going on in class, how much will I score? Guy, I don't know. Like honestly, like people without experience, like one person who, and like I'll see like that just one person, but like one person who came in without experience in 2014 is now graduating in kind of in machine learning with kind of Roger Gross, one of the prominent professors here at U of T as a PhD student. And like anything could happen. I would say the best judge of how much you would score is you, in the sense that you can just take a previous year's exam, you can write it, and you can see how much you score. Usually the adjustment in previous years was, I don't know, like between 5 and 10 points. But like your job is just kind of to do as good a job as possible on the exam. There is usually some kind of adjustment. I don't know if there's going to be an adjustment this year or like how much. Part of the adjustment is like the grading scheme. It's complicated, but yeah, like the answer is I don't know. Why is our exam out of 120? So because like I thought that I should add like an easy question. It was out of 100, and then they thought I should add an easy question, like there's like a missing easy question. And then it was out of 110, and then they thought like 110 looks ugly. And also I thought I like make the initial questions worth more, just kind of to let people kind of build confidence. So the first questions became out of 15, and that's how it's out of 120. But like it's not like you know it's like inflation, like you know, like as long as like everyone's wage went up and the prices went up by the same amount, it doesn't matter that what used to be $100 is now $120, right? Don't take my to your economics class. So, uh, can go over last year's exam 5B. So okay, so we have a list, and what we're doing here is we are making L1, which is kind of a copy that's like 2 levels deep, right? So that means that we're making a shallow copy of this guy, and we're making a shallow copy, which is the same in this case as a deep copy of this guy, right? So that means that so we just made a shallow copy of this. So this means that you modify this, you're fine, but this list is aliased to L1 and 0 at 0. So when you say L at 0 at 0 at 0 is equal to 5, this becomes 5, and that affects L1 as well. When you're saying L at 0 at 1 is equal to 5, that affects L, but it does not affect L1. When you're saying L at 1 at L at 1, sorry, L at 1 at 0 is equal to 5, that affects L, but not L1. You cannot, so like you cannot, so I mean, like you could in principle say, like, you know, like for the things that are themselves list, like go further, but in general you would use recursion in order to do that. One of the questions, I think on 2010, I think there is a question that's kind of like this, that's like flattened, so you could look at the solution for that to be kind of to get the inspiration for how to do recursive deep copy. We have not done recursive deep copy, which is really what you need to do for this. Uh, question 20, so 2016, question 7. Okay, so very quickly. So what's happening here is one of the shapes of trees that we've seen, which is that you start with N, and then that branches out to N over 2 and then over 2. And then those branch out to N over 4. and so on down to 1. So here each call takes the same amount of time. So we count by levels. This is 1 call, this is 2. So 1 is 2 to the 0. This is 2 to the 1. So here there's 4 calls, that's 2 to the 2. And so on up to 2 to the k. So what is 2 to the k? Well, the number of times needed to get to 1 from n by dividing by 2. And that is log to n. Right. So, okay. So total number of calls then is 2 to the 0 plus 2 to the 1 plus 2 to the log to n. And this is something we've done in lecture several times. That turns out to be 2n minus 1. Last part. So I told 0, 0. So here we're saying while I smaller than n and I mod whatever is not equal to 0. So the point here is that here it's always going to be the case that when you get to I equals 10,000, it's going to be 0, and that's going to be it. So this loop is never going to go more than 10,000 times. Even if n is like very large, like n is a billion, this one still goes 10,000 times. So that's a constant amount of times. So that means it's all 1. Are there any built-in functions from Python we need to know the time complexity of? Or, well, like, I mean, just common sense in terms like sum is O and stuff like that, but like nothing like list slicing, yes, we mentioned, but nothing we haven't mentioned, I would say. So kind of the common sense ones like sum, like element in list, things like that. Dictionaries, I would not ask you. Okay. Yes, 2n minus 1 is O. Yeah. All right. 9:42. Sorry, I gotta go. Good luck tomorrow. Bye.
All right. Thank you.